Hi, this is Miss DeLuca, and these are going to be your notes for enzymes. So what you're going to need is a single piece of white paper, something to write with, and then you're going to need these 4 colors, either markers or colored pencil, yellow, red, purple, and blue. Okay, and it's important that you have these colors, okay? So the first thing we're going to do is we're going to make our little notes foldable by taking your paper and then folding it in half hot dog style. And then you're going to fold it in half this way. And then in half again. So we're going to have 4 little squares when we unfold it that we're going to be taking our notes in each little square. Okay? So we're talking about enzymes, and enzymes are the construction screws of your cells. Okay? So I'm going to zoom in a little here. All right, in this first box right here, we're going to write enzymes. All right, and enzymes, they're proteins. They're what we call specialized proteins. And the reason that they're special is because they have a very specific shape, and that shape determines what they do. So in our notes, we're going to draw Pacman. Okay, so you're going to draw Pacman, and he is going to be our enzyme. Okay, so I'm going to give him a little eye, and then we're going to color him yellow, right, because that's what color Pacman is, right? He's yellow. All right, so there's Pacman, and he's living in your body somewhere, and he comes across something that he wants to break down. Okay, he wants to take something apart. So we're going to draw this little piece. It's his matching piece, okay? Now we're going to label this. This is what we call our substrate. That is what we're either putting together or breaking down. And in this instance, we're going to be breaking it down, okay? So you can see the substrate has the same shape as Pacman's mouth, so it's going to be able to fit right in there. This part of his mouth right here is what we call the active site. Okay, it's important that you write all these things down. These are terms you need to know, okay? So this substrate is going to fit right into Pacman's mouth. So we're in our next stage, we're going to draw another Pacman. It's our same Pacman, okay? He's our enzyme, and then this is his active site. Okay? We're going to color him yellow. And then the substrate fits right into his mouth. So we're going to complete the circle, and this is our substrate. We're going to color that purple. Okay, so here's our substrate. It fit right into his mouth. And now Pacman is going to perform science. He is going to create a chemical reaction, and it's actually going to break apart that substrate into its basic parts. So it's like if you stuck 3 Legos together or 2 Legos together, Pacman would be the one separating them apart. Okay, so right now it's still in his mouth. We're still labeling him enzyme. This is still the active site. But now, instead of 1 substrate, we're going to have 2 different molecules. So we started with purple, and the two colors that make purple are red and blue. So he's going to separate those colors. So instead of a purple, we now have two separate things, one that's red and one that's blue. So he physically changes them. And then in our last stage, we've got Pacman again. He's still our enzyme. He's still the same shape. Nothing happened to him. He's cool as ever. Here's our active site again. And yes, you have to write it 4 times so you'll remember. All right, we're coloring him yellow. And now he releases his products. So now instead of one purple triangle, now we have one red triangle and one blue triangle. Okay, and these are what we call products. So these get released. And these are our what's made, and we make products. Okay? So that is the job of an enzyme. We took something that was made out of 2 things. So purple was made out of red and blue, and then it attached to our enzyme. Our enzyme performed a chemical reaction to change their color. They changed, so now we have a single red and a single blue, and then he released those red and blue things, and he'll go off to find another purple triangle to change it into 2 triangles, 1 red and 1 blue. Okay? So we're going to come down to the bottom corner, and we're going to talk about some things that can affect enzymes. All right, so there's a term that you need to know. It's called denatured. And denatured means that the enzyme, his shape got changed, which means he can't work anymore. Okay, it's like he got into a accident and he was a pitcher for the Rangers, and then somebody cut off his arm. Well, he's a different shape now, and he can no longer work. So he is no longer a pitcher for the Rangers. He's a person receiving benefits because his arm got chopped off mysteriously at a baseball game. It's really weird. Anyway, so let's pretend that we have, here's our regular shape Pacman. Okay, he's good to work. But let's say he sat out in the heat too long and he got all melty. That will not work. That will not fit with this puzzle piece. It won't fit in there. So this is when we say it's been denatured. So there are several ways that they can become denatured. So one is if it's too hot. So we have our little Pacman here. And then we've got the sun. Ooh. And he's like, man, I'm hot. He'll start to kind of melt and change shape. And then he'll be all wrinkly and he won't be able to work anymore. He'll become denatured. Another way is if it's too acid or too basic. So if the pH level is too high or too low, It's like pouring acid on a table. It'll pour a big hole in it, and then he won't be able to use it anymore. So if we poured some acid, here's a little beaker of acid, and if you put it on Pacman, he's going to be very upset because you've messed up his face and now he can't work anymore. All right, so things that cause denaturing: too hot, too acid or basic. And there's one more thing that can cause an enzyme to not work very well. In this case, I'm going to draw them with a little earmuffs. And we're going to draw, these are snowflakes because it's snowing outside. And he's going to say brr because he's cold. Okay? So things are too cold, that means it slows down. And he'll slow down so much that he can't work anymore because he's just too cold. It's like freezing. He's freezing cold. And he's like, man, it's just too cold. I'm not going to work. So they'll stop working. So it's like Goldilocks. Can't be too hot. Can't be too cold. Has to be just right. Can't be too acid. Can't be too basic. It has to be just right. Okay? Then in our last little box here, we are going to draw a logo to help you remember what enzymes do. Okay? So what enzymes do is they increase the rate of reaction. And they do this by lowering the activation energy. And activation energy is literally the energy you need to start. Activation means start, and energy is energy. So the energy you need to start the reaction gets lowered. So that means you can do more of them. Okay? And then we can connect them and make a little N, like an enzyme. Get it? Ha 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 ha. Enzyme. So we're increasing the rate of reaction, and then we are lowering the activation energy. And then we've connected them with our purple to make an N for enzyme. It's the enzyme. Okay? So after you've completed these notes, you're going to tape these with the colored side facing out. Don't fold your paper. Don't do this. Don't fold it like this and tape it like this. That's not what I want. I want you to fold it like this so you can see the outside part, and tape this into your notebook onto page 20. Okay? All right. Thank you for watching.